Hey everyone, welcome back to the channel. Today, we're diving deep into the world of the 8085 microprocessor. We're talking data transfer instructions, the backbone of how this chip moves information around. Whether you're a student trying to ace your exams or a seasoned pro working on embedded systems, understanding these instructions is absolutely crucial. So, grab your notes, buckle up, and let's get started. Alright, let's kick things off with the MOV instruction, your go-to for moving data between registers. Think of it like a taxi service for your data. You tell it where to pick up the data and where to drop it off, and boom, it's done. Now the 8085 has a bunch of registers like A, B, C, D, E, H, and L. With MOV, you can move data from any one of these registers to any other. So if you want to copy the contents of register B into register A, you'd use the instruction MOVA B. It's that simple. This instruction is the workhorse of many programs. You'll use it constantly to juggle data between registers, getting everything in the right place for your calculations and operations. It's all about efficiency, people. And hey, here's a little bonus tip for you. The MOV instruction can also be used to move data between a register and memory. We'll dive deeper into that later, but just keep in mind that MOV is a versatile tool in your 8085 arsenal. Sometimes, you need to get specific data directly into a register. That's where the MVI instruction, short for Move Immediate, comes in handy. It's like hand-delivering a package instead of calling for a courier. Let's say you want to load the hexadecimal value 55 into register A. You'd use the instruction MVIA 55H. See how straightforward that is? The H at the end just tells the assembler that we're working with a hexadecimal value. Now, you might be thinking, why not just use MOV for this? Well, MVI is actually more efficient for loading immediate data because it only takes up 2 bytes of memory, while MOV would require 3. Every byte counts when you're working with limited memory space. MVI is your go-to for initializing registers with specific values, setting up constants, or loading data that you know in advance. It's all about that direct approach. Alright, let's say you need to load a 16-bit address into a register pair, like the HL pair, which is often used for memory addressing. Typing out 2 separate MVI instructions would be a real pain, wouldn't it? That's where the LXI instruction swoops in to save the day. LXI stands for Load Extended Immediate, and it's specifically designed for loading register pairs with 16-bit values in one go. Talk about a time saver. For instance, if you want to load the HL register pair with the address 2050H, you'd simply use the instruction LXIH 2050H. The assembler knows that H in this context refers to the HL pair, so you don't need to specify both registers. This instruction is incredibly useful when you're working with memory addresses, setting up pointers, or dealing with any situation where you need to load a 16-bit value quickly and efficiently. It's like using a forklift instead of carrying boxes one by one. Now, let's talk about accessing data stored in memory. The LDA instruction, which stands for Load Accumulator Direct, is your tool for this job. It's like sending a courier to a specific address to pick up a package and bring it back to your doorstep. The accumulator or register A is a special register in the 8085 that's used for most arithmetic and logical operations. So, when you need to work with data from memory, you'll often load it into the accumulator first. To load the accumulator with the data at memory location 2500H, you'd use the instruction LDA 2500H. The 8085 then fetches the byte of data from that memory location and places it into the accumulator. LDA is essential for retrieving data from memory, whether it's variables, constants, or anything else you've stored there. It's like having direct access to your data warehouse. Now that you know how to load data from memory, let's talk about storing data in memory. That's where the STAY instruction, short for Store Accumulator Direct, comes in. It's like sending a courier to a specific address to drop off a package. Just like LDA, STAY works with the accumulator. So, if you want to store the contents of the accumulator into memory location 2500H, you'd use the instruction STAY 2500H. The 8085 then takes the byte of data from the accumulator and stores it at that memory location. This instruction is crucial for saving the results of your calculations, updating variables, or storing any data that you need to keep for later use. It's like having a safe deposit box for your valuable data. Remember how LXI lets you load a register pair with a 16-bit value directly? Well, LHLD does something similar, but instead of loading from an immediate value, it loads from memory. It's like having a moving crew that can transport a whole bunch of stuff from one location to another. Let's say you have a 16-bit value stored in memory locations 2500H and 2501H, and you want to load that value into the HL register pair. You'd use the instruction LHLD 2500H. The 8085 then fetches the byte of data from 2500H and loads it into the L register. And then, it fetches the byte from 2501H and loads it into the H register. This instruction is super handy when you're working with data structures, tables, or any situation where you need to load a 16-bit value from memory into a register pair. It's all about efficiency and convenience. Now, if you can load a register pair from memory, you can bet there's an instruction to store a register pair to memory as well. That's where SHLD comes in, short for Store HL Register Pair Direct. It's like having a moving crew that can take a bunch of stuff from your house and store it in a specific location in a warehouse. Let's say you have a 16-bit value in the HL register pair, and you want to store it in memory locations 2500H and 2501H. You'd use the instruction SHLD 2500H. The 8085 then stores the contents of the L register into memory location 2500H and the contents of the H register into memory location 2501H. This instruction is essential for saving 16-bit values, like memory addresses or data structures, from a register pair into memory. It's like having a dedicated storage space for your important data. Alright, let's talk about indirect addressing. Sometimes, you don't know the exact memory address where you want to store data, but you have it stored in a register pair. That's where stacks comes in, short for Store Accumulator Indirect. It's like giving the courier the address of a safe deposit box instead of the actual address of the recipient. Stacks lets you store the contents of the accumulator into the memory location pointed to by a register pair. For example, the instruction stacks B would store the accumulator's data into the memory location pointed to by the BC register pair. This instruction is super powerful when you're working with arrays, linked lists, or any situation where you need to store data at a location that's calculated or determined at runtime. It's like having a dynamic address book for your data. Sometimes you just need to swap the contents of two register pairs without going through the hassle of using temporary registers. That's where XCHG comes in, short for exchange. It's like having two people swap suitcases with each other in one swift move. XCHG specifically exchanges the contents of the HL and DE register pairs. So if you execute the instruction XCHG, the contents of HL will be swapped with the contents of DE. It's that simple. This instruction is incredibly useful for optimizing code, especially when you're working with algorithms that require frequent swapping of data between register pairs. It's all about speed and efficiency. Now let's step outside the 8085 for a moment and talk about input-output operations. The IN instruction is your gateway to the outside world, allowing you to read data from input devices like sensors, keyboards, or other peripherals. It's like opening a communication channel to receive information from the outside. The IN instruction requires you to specify the port address of the input device you want to read from. For example, the instruction in00H would read data from the input port with address 00H and store it in the accumulator. This instruction is essential for interacting with the real world, gathering data from sensors, or receiving input from users. It's like having a hotline to the outside world. Just like you can read data from input devices, you can also send data to output devices like displays, motors, or actuators using the OUT instruction. It's like sending a command or data to control external devices. The OUT instruction also requires you to specify the port address of the output device you want to write to. For example, the instruction OUT01H would send the data from the accumulator to the output port with address 01H. This instruction is crucial for controlling external devices, displaying information, or sending signals to actuators. It's like having a control panel for the outside world. And there you have it, folks. We've covered all the essential data transfer instructions of the 8085 microprocessor. From moving data between registers to communicating with the outside world, you now have the knowledge to write powerful and efficient assembly language programs. Remember, practice makes perfect. So fire up your simulators or grab your breadboards and start experimenting with these instructions. I guarantee you'll be amazed by what you can achieve with the 8085. Don't forget to like, subscribe, and hit that bell icon so you don't miss out on more awesome tech content. And as always, thanks for watching.